3.2, this is number 3, and it says we have this family of functions p of x equal to x to the third minus ax squared. And it gets a typical member of this, and with a repeated 0 at x equals 0. And why is this a repeated 0? Well, this factors to x squared times x minus a, taking an x squared out of both. So there's a 0 at a and a double 0 at x squared. Now, just from what we know about x cubed starts down here, goes up, wavers, and then goes on up. And that's with that being a positive. The x squared, negative, is an upside down parabola, so it's pulling it down and taking it back up. And since x squared is a double 0, it actually doesn't cross here, but bounces. So it crosses at a, and so if a is over here, it's got to come, let's see, repeated 0, okay, where a is positive, yeah. So it's got to go through here, and it's got to bounce at 0, so it's got to do something like this. And that's what a double 0 looks like, a repeated 0. And it's a double because it's x squared. So that's a typical member of the family. Okay? And then the next thing it says, find all the critical element numbers of p. And so we would just take the derivative of this. This we'd have to do the product rule. Here we don't. So p prime of x would be 3x squared minus 2ax to the 1. And to find the critical numbers, we set the derivative, 3x squared minus 2ax equal to 0. And if we factor out an x, we get 3x minus 2a equals 0. And one of the critical numbers is 0, which we knew already. And another one happens at when this is equal to 0. So 3x minus 2a equals 0 means 3x has to equal 2a, adding 2a to both sides. And dividing by 3, x equals 2a divided by 3. That would be between here and here, or right there. 2/3 of a. So if a is out here 2/3 of the way, 1/3, 2/3, 3/3. 2/3 of a would be about there. And that's where this would be. 2/3 of a. That's creating a shadow there. Okay, so that's the critical number. Compute double prime. Well, we can take the derivative of this. So p double prime of x would be 6x to the 1 minus 2a. And if we set that equal to 0, 6x minus 2a equals 0 means 6x has to equal 2a, adding 2a to both sides, dividing by 6, and x equals 2a over 6, or a over 3, which means at 1/3 of a, here's a, there's 2/3, 1/3 of a is where we have an inflection point. Okay? Hence, construct a second derivative sine chart. Okay? So if it changes sign there, and this is a line, it's a positive slope, and so it goes this way, and so it's negative on this side of a over 2, a over 3, excuse me, a over 3. On this side, it's negative, and on this side, it's positive. You can check that here. Just looking at this, if we put in something smaller than a over 3, like 0, we get negative 2a, and a was positive, so we get a negative value. And if we put something bigger than a over 3, like a, we get 6a minus 2a, which is 4a, and that would be positive, so we get a negative positive sign chart. So concave down because it's negative, and concave up because it's positive. Okay? Describe how the location of the critical numbers and the inflection point of P change as A changes. Well, if we make A bigger, it would still be at 1/3 and 2/3 of A, and A would be the 0. So they all move out wherever A is. 1/3 of the way and 2/3 of the way are the inflection point and the minimum. Okay, so that's 3. 4. So let's move that up there. So we have Q of x equals e to the negative x over x minus c. And c is a positive number, and it's a 1 parameter. C is the only parameter. Explain why Q has a vertical asymptote at C. Well, it has a vertical asymptote because that's where it's going to be division by 0. And so when x minus c equals 0, adding c to both sides, that's when x equals c. Okay. B. What happens when we let x get really large? Well, if x gets really large, this gets large, but this gets small. So we've got e to the negative x looks like this. And so it's getting smaller and smaller and smaller as we go out here large. And this gets bigger and bigger and bigger. So we got small over really large. Small over really large is really small. So this is going to approach 0. And what happens when it goes to the negative? Well, this would be a negative number and large in size, but very small since it's going to the negative. X minus c crosses at C, has an x-intercept at C, crosses at C, where the vertical asymptote, and it looks something like the slope of 1. So negative numbers times this, or divided into that, will make a negative curve. So this thing has to go up, and then it's going to come, when this is 0, it's going to come down, be 0 when we divide it, or be undefined. So it's going to go like this, I believe, and then it's going to do something over here that gets sucked down, going big, but towards the negative because we're multiplying by negative. But anyway, as we go to the negative side, this is going to infinity, this is going into infinity, but this is going much faster to infinity. So this will be larger than this, and so, but this will be negative, that'll be positive, so it's going to go to negative infinity. Okay, there was a lot there in that, so hopefully you understood that. You can listen to it again. All right, Q prime. Define critical numbers. So we've got to take the derivative of this, which is a quotient rule. A prime b minus b prime a over b squared is a quotient rule. The derivative of the numerator, derivative of e to the x is e to the negative x is negative e to the negative x times the derivative over there, which is negative 1, times the denominator, minus the derivative of the denominator, which is 1, because derivative of the constant is 0, times the numerator over the denominator squared. Okay, so this is squared. C is positive. In the original problem up there, it says positive. So when x equals c, it'll be 0. be an asymptote, vertical asymptote, but otherwise it's going to equal 0 when this numerator is 0, and that's where the critical numbers are going to be, and there's e to the negative x and a negative 1 in both of these, so I could take out negative 1 e to the negative x, and I'd have left this x minus c plus 1. This times the x minus c is this first part, and this times plus 1 would be the negative 1 e to the minus x. This is going to be 0. This would have to be the 0. So we have x minus c plus 1 equals 0. So x would equal, subtract 1 and add c, so c minus 1. That's the critical number. Happens at c minus 1. Well, c is where the asymptote is, and if you move 1 unit back, and I don't know how much that is, that's going to be where it peaks out. Well, this thing does something like this, so that's where it's going to peak out, 1 unit back from the vertical asymptote. 1 less than wherever c is. And then it's going to go like this, never be 0 slope there, only 0 slope right there. So that's what we found out with that. And construct the first derivative sine chart. So below c minus 1, below this critical number, it would be something down here like negative c. So negative c minus c, that's negative. And this is negative, and this is positive. So all of this would be negative times a negative times a positive. This is a negative minus, this is positive, so minus some more. So the numerator is negative, and the denominator is squared, so it's always positive. So we get negative below this place. Oh, this is negative times the negative is positive, excuse me. And let's look at this numerator here. This will help us. So if we look below c minus 1, this will be negative times the negative is positive over a positive. It will be positive over here, which has a positive slope. It should be negative in here, and it should be negative here because that's negative slope and negative slope. And so if we do something bigger than c minus 1, like 2c minus 1 minus c plus 1, 2c minus c is 1c, and the minus 1 plus 1 are gone, so that's plus c, so that's positive, this is negative, and so all of this will be negative in here and negative out there. So negative slope and negative slope. That's the first derivative sine chart. And determine what it gives us. Well, it gives us a local maxima right there at c minus 1. 1 to the left of the vertical asymptote. And there's no minimum. This keeps going down here, and these both keep going down, so there's no local minimum and nothing else. And sketch a member of the family, and I did that. All right.